We'll go with the examples. Rijo. Rijo is 7th from the left end of a row. And Harshad. Harshad is 4th from the right end of a row. And if Harshad is 2nd to the right of Rijo, then how many persons are there in this row? That's a question. So Rijo, 7th from the left end. There are 6 persons to the left of Rijo. And Harshad is 4th from the right. There are 3 persons to the right of Harshad, right? And at the same time, it says that Harshad is 2nd to the right of Rijo. From the left end, Rijo is 7th. If from the left end Rijo is 7th, Harshad would be 2 places to the right of Rijo. So from the left end, Harshad would be 9th. So that means how many persons in between them? In between them, just 1 person. So ultimately, it is up to here it's 7. 7 plus 1, 8. 8 plus 1, 9. 9 plus 3, 12. There are 12 persons in that arrangement. Or you count it this way. Up to, from the left end up to here it's 7. From the right end up to here it's 4. 7 plus 4 is 11. And in between them 1. It's 12. So 12. So this is pretty much simple questions. Simple example from that area. Another example we have. Let's say Manu. Manu is 10th from the left end of a row. And Priya. Priya is maybe like 8th from the right end of a row. 8th from the right. So it's 10th from the left. And Priya is 8th from the right. If Manu is 5th to the left of Priya, Manu is 5th to the left of Priya, then how many persons are there in this arrangement? That's a pretty similar question as we have done earlier. So from the right end, Priya is 8th position. And Manu is what? 5 places away from Priya, right? So the position of Manu from the right end must be 13. 8 plus 5 is 13. So if 8 plus 5 is 13, then this is the 8th person. 9, 10, 11, 12. There are 4 persons in between. So ultimately, from the left end, Manu is 10. From the right end, Priya is 8. So 10 plus 8 is 18. 18 plus 4, it's 22 persons. So how many persons in this arrangement? There are 22. Another one, so let's say, in a parking lot, we see that Tata Nexon is parked in the exact middle. So Tata Nexon, it's parked in the exact middle. If there are 14 cars to the left of this Tata Nexon, then how many cars in that parking lot, in that row? So Tata Nexon is parked in a row inside a parking lot, and it's exactly in the middle. There are 14 cars to the left of Nexon. So 14 cars to the left of Nexon, and how many cars to the right? Because Tata Nexon is parked exactly in the middle. So how many to the right? Another 14 towards the right. So pretty much 14 plus 14, 28 plus 1, 29 cars in this arrangement. Now another example we have, in a row of students, Tia is 10th from the left end. Tia is 10th from the left end. And Ramya is 7th from the right end. 7th from the right end. And if there are 3 students in between them, then how many students are there in this row? So Tia is 10th from the left, and Ramya is 7th from the right, and 3 in between. So at a glance, we can see that from the left up to here, it's 10. From the right up to here, it's 7. So 10 plus 7 is 17. 17 plus 3 is 20. However, this question is a bit interesting. We have conditions given. Tia is 10th from the right, Ramya is 7th from the I mean, Tia is 10th from the left and Ramya is 7th from the right. In between them, 3. So these 3 conditions given to us. We cannot change any of these conditions. However, the question doesn't tell us about like Tia is to the left of Ramya or Tia is to the right of Ramya. It's not really mentioned in the question. So that means, is it possible for Tia to be the right of Ramya and Ramya to be the left of Tia? All other conditions, given conditions, must stay exactly as it is. We cannot change it. We are not supposed to change it. Okay, let's try this. If Ramya comes over here, let me mark it with a different color. If Ramya comes over here and Tia goes here, the conditions, that means the number of persons in between them, that must be exactly same as the previous case, 3. It must be 3. And the position of Tia must be 10th from the left end. That means to the left of Tia, there must be 9 persons. So 9 persons to the left of Tia. 9. Here we have 3. 3 plus 1 is 4. And total we need to have 9, right? So if it is 9, we need to have 5 more persons here. So count it. 5 plus 1, 6. 6 plus 3 is 9. And Tia is 10th from the left end. Yes, Tia is 10th from the left end. So that condition is not changed at all. That's the same condition as we have in the previous arrangement. Okay, so now we'll take away this part. Now look at the second part. Second part means Ramya is what? 7th from the right end. Ramya is 7th from the right end. To the right of Ramya, there must be 6 persons. Look at that. 6 persons to the right of Ramya. If it is 6 to the right of Ramya, count it. We have 3. 3 plus 1, 4. We need to have 6, so we have 2 more. So 2 plus 1 is 3. 3 plus 3 is 6. And Ramya is 7th from the right end. Yes, Ramya is 7th from the right end. So that condition satisfied as well. So ultimately, what we see here is second arrangement is possible. This arrangement, the second arrangement is possible. The first arrangement is possible. And the second arrangement is possible as well. If second arrangement is possible, keeping all the given conditions, Ramya must be Tia must be 10th from the left end. Yes, Tia is 10th from the left end. And Ramya is 7th from the right end. And there are 3 persons in between them. So in that case, if second arrangement is possible, how many persons in the second arrangement? Look at this. Up to Tia, we have 10 from the left. And how many more? 2 more. So what is it? 10 plus 2, 12. Or you count it this way. 5 plus 1 is 6. 6 plus 3 is 9. 9 plus 1 is 10. 10 plus 2 is 12. Perfectly all right. So this question, what is the answer? It is not really 20 or 12. The answer must be either 20 or 12. These kind of questions, usually the answer choices you may expect this way. A, B, C, and D. First answer choice would be 20. Most of the candidates may mark that answer. The reason for that, they may look at the first possibility, they may not think about the second possibility. So that's a trap. So definitely they'll give their first answer or second answer choice is 20. And the next one would be like anything which may not be related with that, 17. And the third answer choice is 12. Last answer choice would be either A or C. Either answer choice A or C. This is what it is. So these are the answer choices you have. Now question number 1. We'll take a look at this questions here. Kuldeep is 13th from the left and Tina is 9th from the right in a row of students. If the 5 students are between Kuldeep and Tina, then how many students are there in the row? So we'll take a look at that. The first arrangement we have Kuldeep. Kuldeep is what? 13th from the left end. There are 12 persons to the left of Kuldeep. And Tina is ninth from the right end. Tina is ninth from the right end. So there are 8 persons to the right of Tina. And how many in between them? There are 5 in between them. 5. So ultimately, from the left, we have 13. From the left, we have 13. From the right, we have 9. So 13 plus 9 is 22. So 22 plus 5. How much is that? 22 plus 5? 27, right? So we have the answer choice 27 here. However, is there a second choice? Second arrangement possible here or not? Look at the answer choice 27, we have 10, we have 15, and there is an answer choice not sure. Not sure is like data inadequate, or we can say that cannot be determined. Cannot be determined means if we have more than one answer, we cannot say which one is the exact answer. So cannot be determined, not sure, data inadequate. These answer choices indicate the possibility of a second arrangement. It's not necessarily in all cases, but there is a chance. So we'll take a look at what is the second arrangement here. Let's try this. Second arrangement, is it possible or not? If it is second arrangement, the given conditions, we cannot change it. So what we do, without changing the given conditions, we'll bring Tia here. What is her name? Tina. Okay, Tina here and Kuldeep here. And how many in between them? 5. And to the left of Kuldeep, there must be 30. Kuldeep is 13th from the left, and to the left of Kuldeep, there must be 12. So 12 to the left of Kuldeep, and he's 13. So here it must be 12 to the left of Kuldeep. So we have 5. 5 plus 1 is 6. We need 12. So we need 6 more. 6 plus 1, 7. 7 plus 5 is 12. Kuldeep is 13th from the left end. And look at this girl, Tina. And Tina is what? 9th from the right end. So to the right of Tina, there must be 8. So here we have, to the right of Tina, we have 5. 5 plus 1 is 6. We need 8. So 2 more. Just if you really want to confirm it, we can count it once again. Otherwise, it is perfectly all right now. So count it from the right hand. 2 plus 1 is 3. 3 plus 5, it's 8. 8 plus 1 is 9. So that Tina is 9th from the right hand. So second arrangement is possible. Second arrangement, what is? Kuldeep is 13th from the left hand. Up to here is 13. 13 plus 2, we have 15. And the first arrangement, it was 27. First arrangement, 13. 13 plus 9 is 22. 22 plus 5, 27. So that's 27. So the answer is either 27 or 15. If you have an answer choice either 27 or 15, or you have either answer choice 1 or answer choice 3, then that would be the best answer. In this case, we don't have such an answer, but we have an answer choice which is given not sure. Yes, we have 2 answer choices, 27 and 15. We are not sure which one is the best answer. So the answer is what? 4. Not sure. Okay, next one. 10 tourists entered the exhibition hall before the guide A and 15 tourists after guide B. How many tourists entered the exhibition hall if 8 tourists entered between A and B? So we'll try that. 10 tourists entered the exhibition hall before guide A. So here it's guide A. How many? 10 tourists before A. And 15 tourists after guide B. So guide B. After guide B, there are 15 tourists. How many tourists entered the exhibition hall if 8 tourists entered between A and B? So between A and B, we have 8. So how many we have total? 10, 8, 15. So 25 plus 8. 25 plus 8, 33. Do we need to include A and B? Well, A and B are guides. What is the question? How many tourists entered the exhibition hall? We don't need to count the guides. We need to count the tourists. So we need to count what? 10 plus 15, it's 25. 25 plus 8, 33. So 33 is good. However, is there a second arrangement possible here? The question doesn't say that guide A entered first and guide B after that. It is not really mentioned that way. So guide B can enter first and guide A can after B. So that's a possibility open for us. We'll try that possibility. B is here and A is here. And given conditions, we cannot change it. So that means in between them, 8. And before guide A, how many must be there? There must be, before A, there must be 10. So we have 8. And in this case, B cannot be counted because B is the guide. So there must be 10 tourists before A. So 8 tourists here. There must be 2 tourists here as well. So 8 plus 2 is 10. And after B, how many after B? After B, there must be 15. So we have 8 here. And this A cannot be counted. So we need to have what? Total 15. So 8 is already there. Then we need to have a 7 more. So 8 plus 7, 15. So this is what we have, the total in the second arrangement. So it's what? 8 plus 2 is 10. 10 plus 7, 17. So this is 17. And in this case, it's 33. So 33 and 17. In this case, second answer, like the 17 answer, second answer choice 17, that is not really given here. Here it's 15, here it's 39, here it's 33. So is the answer 33? Should we mark the answer 33 or should we go for cannot be determined? There are two answers here, 33 and 17. So in this case, always remember one thing. If you have, instead of 15, if it is 17 is given, you don't have any confusion. In this case, the answer is what? Cannot be determined. So we are not sure whether 17 or 33 is the answer. Cannot be determined means, it doesn't mean that we cannot find the answer. We got the answer, but there are two possibilities. So we cannot say which one is the correct answer. That is, the situation cannot be determined. So here we have 17, we have 33, we cannot say which one is the correct answer. However, in the question, it is not given in that way. It is given as 15, 39, 33. So, well, 33 is there, but second answer choice or second possibility, 17 is not there. That case, do we mark 33 or do we mark cannot be determined? If you mark 33, what does that mean? So it means you looked at this question and you have seen only one answer. That means you have seen only one possibility. That's the meaning of 33. If you have answer choices something like this, let's say A, B, C, D. First one is 33. Second one is, let's say, 39. And third one is, let's say, 18. And the last one is 21. So this case, there are two different possible answers, 33 and 17. However, we don't have 17 here. We have 33 here. The only possibility we have here, the possibility what we have, the option is 33. Because we don't have an answer choice to indicate there are two possibilities. But in this case, it is different. You have one of the answer 33 is there. If you mark that answer, it means you have seen only one possibility. You have checked only one possibility. Since you have an answer choice cannot be determined, the best option for this question is cannot be determined. That cannot be determined, it indicates that you have looked at this question and you have seen two different possibilities. Since you don't have both possibilities here, that means like either it is 17 or 33, we don't have such a possibility here. Since we don't have such a possibility, we go for the best available answer choice. What is it? Cannot be determined. Cannot be determined means we cannot say which one is the exact answer. It means more than one answer is there. More than one possibility is there. So always remember that part. However, this case, as I have mentioned, we cannot have an answer choice like cannot be determined or not sure, data inadequate. That option is not there. So the only possibility what we have here is mark 33 and move away from that question because we don't have any other option there. So next question number 3. Jaya is 7th from the left end and Rani is 10th from the right end. Okay, so then how many are there in the row if there are 6 persons in between them? Let's look at that. Jaya is 7th from the left. So 7th from the left. That means how many on her left? 6. And Rani is 10th from the right. So Rani, 10th from the right. 10th. How many on her right? Her right, we know that there are like 9 persons. And how many students are there in the row if 6, rather than persons, use the word students. If 6 students are in between them. The question is how many students are there in the row if 6 students are in between them. So 6 in between them. Now we counted up to here it's 7, up to here from the right, up to here it's 10. So 10 plus 7 is 17. 17 plus 6, that's 23. 17 plus 6 is 23. Now is there a second arrangement possible? Well, it doesn't say that Jaya is to the left of Rani or Rani is to the right of Jaya. That means we can think about a second arrangement. So let's try the second arrangement. So Rani is here, Jaya goes here. How many in between them? 6. Okay, to the left of Jaya, we have 6. To the right of Rani, Rani is 10th from the right. So to the right of Rani, there must be 9. So look at this. Rani is here. To the right of Rani, we have 6. 6 plus 1 is 7. 7 plus 2, 9. So 2 plus 1 is 3. 3 plus 6 is 9. So Rani is 10th from the right. Perfectly all right. How about Jaya? To the left of Jaya, Jaya is 7th from the left. So to the left of Jaya, that must be 6. So look at this. Look at the left of Jaya. Already we have 6. Including this Rani is going to be 7. What's the condition given? It is exactly 6. So count it. Rani is 1. 1 plus 6 is 7. And Jaya becomes what? 8th from the left end. Jaya must be 7th from the left end. In this case, Jaya is 8th from the left end. So that means this arrangement is not accurate based on the given conditions. So we have to ignore that arrangement because that arrangement doesn't go with the given conditions. So second arrangement is not possible in this case. Previous cases, we have seen that second arrangement was possible, right? Second arrangements were possible. But this case, it is not. So now, what is the answer? Second arrangement is not possible. We have only one answer. What is it? 23. So even though we have the answer cannot be determined indicates to the possibility of what? More than one answer. In this case, we have only one answer. So 23 is the answer. 23. And why exactly that happened? The previous questions, previous arrangements, we had 2 different arrangements. And in this case, we have only one arrangement. Why is that? So if you take a look at these arrangements here, first arrangement. So there are like Kuldeep and Tina. So there are 12 to the left of Kuldeep and Tina. 8 to the right of Tina. Tina is 9th. And there were 2 possibilities. So here we have 12, here we have 5, here it's 8. And second question, here we have to the left of A, it's 10. To the right of B, it was 15. And in between them, 8. 2 arrangements. This case, what is it? To the left of J is 6. To the right of R is 9. In between them is 6, but we have only one arrangement. Is there a peculiarity here? If we can identify the difference between question number 1, 2 and the third one. Questions 1 and 2, we had 2 different arrangements. Question 3, we have only one arrangement. So if we can identify that difference, and it's easy for you to deal with this kind of questions. When you get a question, you get an idea whether this question has 2 arrangements or one arrangement. So that gives a kind of like a lot of confidence for you to deal with that question. So let's look at that questions 1 and 2. So I want your attention on these numbers here. Kuldeep is 13 from the left end, and to the left of Kuldeep we have 12 persons. And Tina is 9 from the right end. On the right of Tina there are 8 persons. So look at these two numbers, 12 and 8. Which is the minimum number? 12 and 8. When you consider those two numbers, the minimum number is 8. And the number in between Kuldeep and Tina is less than the minimum number. Here the minimum number between 12 and 8 is 8. And the number of persons between Kuldeep and Tina is less than that 8. So in that case we had 2 arrangements. And second question, so we have to the left of A we have 10. And to the right of B we have 15. So if you look at these numbers 10 and 15, which is the smallest number? Of course that's 10. And the number in between these two, it's less than that 10. So we had 2 arrangements. Now we'll look at the third question. Third question we have to the left of Jaya it is 6, and to the right of Rani it is 9. So when you consider these two numbers 6 and 9, which is the minimum number? 6 is the minimum number. And the number between Jay and Rani, it is not less than 6, it is equal to 6. So number in between them, if it is equal to the minimum number or more than that minimum number, will have only one arrangement. But this number, if it is less than the minimum number here, and you consider 6 and 9, the minimum number is 6. So if this number is less than the minimum number, for example, this number is 5, then there are 2 arrangements. If this number is 4, there are 2 arrangements. If number is 2, 2 arrangements. However, if the number is like the number in between, is it equal to the minimum number, or if it is more than, in this case it is equal, so we have only one arrangement. If it is like 10, that means it is more than the minimum number. In that case, we will have only one arrangement. Or this case, if it is 8, that means that 8 is more than 6. So in that case, we will have only one arrangement. So be aware of this kind of simple things, but these are the real shortcuts to the quotients, these kind of quotients. Number 4. Certain number of chocolates was distributed among 6 children, J, K, L, P, Q, R. And these are the children, J, K, L, P, Q, and R. K received more than only J. So what exactly the question asks us to do? R received more than K, R received less than L, Q received more than L, but he did not get the highest. Who among the following got less than L? So ultimately, we have to have an arrangement of the children who had received these chocolates, and based on the number of chocolates they have received. So we'll make an arrangement. So that's called, these type of questions are called arrangement type questions. So maximum number. So the child with the maximum number of chocolates and the child with the minimum number of chocolates. Or you can make it the other way. Maximum number can be here and the minimum number can be here as well. Doesn't make any difference. So what it says, there are like, how many children are there? 6 children. K received more than only J. K received more than only J. That means K is here. K received only more than J. That means nobody else, other than J, nobody else got less than K. That's what it is. And R received more than K. R got more than K. So R could be any one of these positions. So R received more than K. We have no idea where exactly R is. And R received less than L. So R got less than that of L. And Q received more than L. Okay, so Q received more than L. At the same time, he did not get the highest. So Q cannot be the highest. Now we have an arrangement R, L, Q. R less than that of L and L less than that of Q. So that is in an order. And Q cannot be here. The only possibility we have is R, L, Q. Now only one child is missing over here in this arrangement. Who is that? we have children J, K, L, P, Q, and R, right? So we have J, K, L, P, Q. P is missing here, so P must be here. There's only one slot open for P. We'll put P right here. Now this is the arrangement. Once you got this arrangement, P got the maximum and J got the minimum, and this is what it is. And the question, who among the following got less than L? So less than L. Who are the children got the chocolates less than L? So J, K, R. So we have J, K, R. Answer here. That's a relatively straightforward, simple question. Number 5. In a row of boys, Kailash is 9th from the left. So Kailash is 9th from the left. So there are 8 persons to the left of Kailash. And Javed is 14th from the right. So Javed, 14th from the right. So there are 13 persons to the right of Javed. So 14 from the right hand. And this guy is 9th from the left hand. And if they interchange their positions, well, how many in between them? It is not really mentioned so far. We'll look for it. If they interchange their positions, Kailash becomes 28th from the left. Then how many boys are there between them in the row? So that's a question. Actually, they are looking for the number of persons in between them. We have no idea how many. It is not given here. We are looking for that number. What is the condition given here? If they interchange their positions, Kailash becomes 28th from the left hand. So if they interchange, what happens? Interchange means Kailash goes to the position of Jayesh. So Kailash is here. If Kailash comes over here, you know what? Kailash goes exactly to the position of this guy, Jayesh, then the number of persons to the right of Jayesh would be exactly same on the right of Kailash. So there must be 13. Now this Jayesh goes to this position of Kailash. So the number of persons to the left of Kailash must be to the left of Jayesh. Number of persons to the left of Kailash must be left of Jayesh in this case, after the interchange. So this is the first possible arrangement. This is the arrangement after the interchange. Now after the interchange, when they are J is here and K is here, and how many in between them, still we have no idea. We'll keep it as open. And the condition says that Kailash becomes 28th from the left. So this Kailash is 28th from the left. So 28th from the left. If he is 28th from the left, the number of persons to the left of Kailash must be how many? Must be 27. Up to here it's 27 and Kailash is 28th. So if that is the case, how many boys are there between them? That's a question. How many boys between them? So this total must be 27. We know that this is 8 plus 1 is 9. And altogether must be 27. So 9 is already here. We need to get 27. So the answer for this question, or the number of persons in between them, must be 18. So count it. 8 plus 1 is 9. 18 plus 9 is 27. And Kailash is 28. Perfectly all right. So how many persons in between them? It's 18. Number 6. How many such pairs of letters are there in the word substance, each of which has as many letters between them in the word, both forward and backward directions as in the English alphabet series? So how many such pairs of letters are there in the word substance in such a way that each of which has as many letters between them in the word as in the English alphabets? So it can be both forward and backward directions. If you get an idea about the question, it's perfectly all right. Otherwise, we'll take a look at that, what exactly the question asks us to do. So what is it? Substance. Substance. And English, it talks about English alphabets as well, right? So English alphabets, we have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, etc. It goes like this. And we need to find how many such pairs of letters are there in the word substance, each of which has as many letters between them, in the word as in the English alphabet series. So, in English alphabet series, the number of letters between a pair of letters. For example, the best example we can hear here, it's like, look at A and C. We have A and C are here as well. So in English alphabets, between A and C, how many letters are there? Only one letter. That could be any letter. No need to worry about which letter is that. In this case, B is in between, so that's only one letter, right? And look at A and C here. How many letters are between A and C? Except one letter. It doesn't matter which letter is that. That's perfectly all right. We are looking at the number of letters. So this is what, how many such pairs of letters in the word substance, each of which has as many letters between them in the word, as many letters, and as many in English alphabets, that must be in the word as well. English alphabets, between A and C, we have only one. So in this case, between A and C, one. So between A and C, we have one. So that A and C, the letters A and C, we can take it as a pair exactly as it is in the English alphabet. So we have one pair, A and C. Is there any other pair? I'm pretty sure many of you caught it by this time. So what is it? S and T. Look at that. In the English alphabet, S and T. S and T are consecutive letters. There is no letter in between S and T. So that's a similar situation right here. S and T. There is no other letter. So that means S and T as exactly as in the English alphabets. So we have another pair, S and T. Is there a third pair here? Third pair, if you look at this way, S. In English alphabets, we have S, T, U. So between S and U, so we have S here and we have U here. Between S and U, how many letters are supposed to be there? One letter. It could be both forward and backward direction. So it could be forward, backward, doesn't matter. So this S and T can be forward, or like U and S can be backward, like doesn't matter. So this case, U and S, that's in the backward direction. Still, that's okay. But how many letters between U and S? If it is backward, one letter. If it is forward, one letter. Doesn't matter. So this case, exactly one letter between U and S. So that's U and S can be, U and S is exactly as it is in the English alphabets. So that's U, S is the third pair we have. So the answer is we have one. So one cannot be the answer. We have three pairs here. Two cannot be the answer. We already have three pairs. Now the answer is none of this can be a possibility. That means if you have an answer 4, that means 4 pairs are here. Then among the answer choices, you don't have such an answer. So naturally we go for the answer, none of this. Since we have the answer choice, none of this, we have to count, or we have to check, is there any other possibility here or not. Instead of none of this, if this answer choice is given as like 0 pairs, that means 0 cannot be an answer. Then in that case, we could have confirmed this 3 as the answer. But since we have the answer choice none of this, we need to check the possibility of, is there any other pair possible or not. So the best way to deal with this, at a glance, if you don't get those pairs, what I suggest is go for taking each letter. For example, if you take S and U, there must be one letter in between, right? So S and U, not exactly that pair. S and B, not possible. S and S, not possible. S and this T, it is not possible. This S and this T is possible. This S and T, it's not possible. S and A, no way. They are not exactly in the English alphabets. And S and N, well, if you look at from N, N, O, P, Q, R, S must be here. It is not here. So S and N is not possible. And S and C, no way it is possible. And S and E, well, S is 19, E is 5. Between I mean, 19 and 5, the difference is 14, right? So there are 13 letters between S and E. We don't have 13 letters between S and E. So S is out. Now look at U. U, B, no way. U and S, we already have taken that, U and S, that's fine. Then U and T, well, U and T are consecutive letters. So in this case, U and T is not possible. U and A, absolutely not. How about U and N? N, O, P, Q, R, S, no way. Then U and C, absolutely not. U and E, no way. Then look at B and S. B and S, no. B and T, no. B and A, actually there is no letter between B and A in English alphabets. Here we have two letters. So B and A is not a pair. B and N, no. B and C, no way. B and E, no. Then S and T has already been taken. S and A, no way. S and N, S and C, absolutely not. S and E, no. Then T and A, no. T and N, no. T and C, no. T and E, no. Then A and N, absolutely not. A and C, it's already been taken. Then A and E. If it is A and E, how many letters between A and E? There must be 3 letters. But in this case, between A and E, we have only 2 letters. So A and E cannot be taken as a pair according to the directions given here. So A and E is not possible, so A is out. Then N and C, absolutely not. N and E, no way. And C and D, there must be at least 1 letter. Not at least, exactly 1 letter. 1 letter between C and D. We don't have any letter between C and D. So C and D cannot be taken as the pair. So ultimately, there is no other possibility here. Only one possibility. I mean, among the answer choice, there is only one answer we have. It's 3. So 3 such pairs are there. And there are like interesting questions of that sort. We may take another example here. Red tape. Red tape. How many such pairs are there? Let's take a look at that. So E and D. At a glance, I can see that E and D are consecutive letters, E and D. So D and D or E and D doesn't matter. So we have one such pair, E and D. Then R, S, T. Well, R, S, T. If T comes over here, that would be a pair. But R and T, in this case, R and T cannot be the pair. Then how about like A and D? Between A and D, there must be 2 letters, right? Here we have only 1 letter between A and D. Between A and E, there must be 3 letters. But in this case, we have only 2 letters. So A and D doesn't work. Then how about T and P? No way. How about A and this E? Not really. How about D and this P or A or E? So that case, if you are not really getting it further, what we do, we'll take 1 letter at a time. So R and D, no. R and D, no. R and T, we have checked. R and A, no way. R and P, there must be exact 1 letter between R and P, but in this case, we have 4 letters, so that doesn't work. R and D, no way. Then E and D is already been taken. E and T, no. E and A, we checked it, doesn't work. E and P, no. E and E, no. Then D and T, no. D and A, no way. And D and P, no. D and this E, no. And T and A, T and P, T and E, Then AP, no. AE, no. Then PE, no way. So only 1 pair is possible. All right, move on. Number 7. In an examination, Q got more marks than M. So it's again an arrangement. So that's based on the marks. So how do we make that arrangement? Maximum on one side and the minimum on the other side. In an examination, Q got more marks than M. Q got more than that of M. So maximum on this side, minimum on this side. Q got more than that of M, but not as many as N. So Q got less than that of N. And N got more than that of J and K. So N got more than that of J and K. So J, K. However, among these two, J and K, we don't have a comparison given. That means J may have less than that of, I mean, K may have a less than that of J, or K may have more than that of J. So Kj is possible, or Jk then N is possible. So there are two possibilities. Then J got less marks than M. So J got less than that of M, but his marks are not the lowest in the group. So J is not the lowest. There is at least one person here, less than that of J. How many persons are here? We have Q, we have N, we have J, K, then M as well. So Q, M, N, J, and K. So there are 5 persons, correct? So the 5 persons, we have 4 right here. Then who is the person can have marks less than that of J? M cannot have it. M is more than that of J. Q cannot have it. N cannot have it. Then the only possibility what we have is for K. K must have something less than that of J. So K must be here. So according to the given conditions, we have, this is the arrangement, K, J, M, Q, N. So now, who is second in the descending order of marks? So descending order of marks from this side. So Q, who is second? So second, that is Q. And the descending order, that's Q. Now let's try the next one. 6 computers. A, C, D, E, F, and G. So there's 6 of them. A, C, D, E, F, and G. If it is A, C, D, F, and G, how many are there? Is it 6 or 7? You see that B is missing here, B. So that means exactly 6. And they are serviced on a different day of a week, starting from Monday to Saturday. So there are 6 days from Monday to Saturday. And computer F is serviced on Thursday. 2 computers serviced between F and A. Computer E is not serviced on the days immediately before or immediately after the day when the computer F is serviced. Computer C is serviced on the day immediately before the day on which computer G is serviced. Computer C is not serviced after D. That means computer C must be serviced before D. So these are the conditions given to us. Let's try this. Try the arrangement. 6 computers, right? So 1, 2, 3, 4, 5, 6, 7. 6 days, 6 computers. So 1 day, 1 computer. Actually, it is 7, right? So we need just 6. Okay, fine. So computer F is serviced on a Thursday. So let's say if it is Monday, Tuesday, Wednesday, Thursday, computer F is on a Thursday. 2 computers serviced between F and A. 2 computers between F and A. So if like 2 computers serviced here, 1 and 2, then A must be here. But that's not possible because this is end of the week. This is Saturday. We cannot go beyond that. Now the next possibility, 2 computers between F and A. So there are 2 computers and A must be here. So A is confirmed. Computer E is not serviced on the days immediately before or immediately after the day when the computer F is serviced. So F and E cannot be serviced on consecutive or adjacent days. So E cannot be here, E cannot be here. So that's what is done. So E can have the service on any other day. E can be here or E can be here. 2 possibilities. Then computer C is serviced on the day immediately before the day on which G is serviced. So C must be immediately before G. C and G must be on consecutive days. And if you take it this way, C and G on consecutive days, that means C and G can be here, right? Or C and G can be here. If C is here and G is here, what happens then? Then we'll have E here, and which is the computer missing over here? D. So D must be here. But what is the condition here? Computer C is not serviced after D. If D comes over here, then computer C is serviced after D. So that arrangement is not possible. So that means C and G cannot be here. So we'll bring that C and G here. C and this is G. Now we cannot have E here, then E must be here. And which is missing? D. So computer D must be here. And computer C is not serviced after D. That means C must be before D. Yes, C is before D. That part is good. Now, how many computers are serviced between C and D? How many between C and D? Look at that. Between C and D, how many computers? 2 computers are serviced between C and D. Now, we have same directions, but the question is different. Which of the following computers is serviced on Tuesday? So look at that. Which is on Tuesday? Well, Monday, this is Tuesday. So C is on Tuesday. Next one, A is related to G in a certain way. So it is based on the same arrangement. We have a question. A is related to G in a certain way. So we'll bring the arrangement here. That's easy for us to deal with that question. So what is the arrangement? A, C, G, F, D, E. A, C, D, F, G, E. Okay, so that's the arrangement. This is Monday, it's Tuesday, Wednesday, Thursday, Friday, Saturday. A is related to G. So what is that? A is related to G. Look at this A here, G here. A is related to G. In a certain way, as F is related to E, and F and E, how come that F and E are related? F is here, E is here. So now A is related to G. What we see here, there is one computer, exactly one computer is serviced between A and G. Same way, exact one computer is serviced between F and E. So possibly that is the common factor we see over here. So A is related to G in a certain way, F is related to E. Then, if based on that, which of the following is related to C? The same pattern. The same pattern which is related to C. Well, if we take that exact one computer is in between, one computer service in between, then C must be related to what? C must be related to one computer in between. It must be related to F. So answer must be F. Let's get into the figure partition type of questions. So figure partition and counting. So what we see here, here is a figure. This is square. That square is partitioned into smaller pieces. And the question, how many squares are there in the given figure? So how many squares? Well, we have a large square, then we have a number of small squares here as well, right? So what is your answer? What do you think? Here we have 16 small squares are there, right? 16 plus 1, 17. Is the answer 17? However, among the answer choices, we don't have 17. We have the answers more than that. So naturally, from the answer choice itself, you get an idea 17 is not the correct answer. There must be something more than that. So let's take an example here. In this case, we have let me make that square. So it's a 3 by 3 square, and what we have in the question is a 4 by 4 square. In this 3 by 3 square, how many total squares are there? 3 by 3 means 3 rows and 3 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Ultimately, when we count one piece at a time, when we consider one piece at a time, we have 9 squares. So square one piece at a time. S1 means one piece at a time. We have 9 of them. And how about we consider 2 pieces at a time? That means 1 and 2 together. That is not a square. It's a rectangle, 1 and 2 together. How about like 1 and 4 together? 1 and 4 we take together. It's again a rectangle. And 1 and 5, if you take 1 and 5 together, it's a rectangle. So S2, that means 2 pieces together, we don't get any possibility. S2 doesn't work for this question. And S3, any 3 pieces together is the square. For example, 1, 2, 3 together, it's not a square. Again, let's say if you take 1, 2, and 5, that is not a square. 1, 2, 5, these 3 pieces, that's not a square. If you take 1, 4 and 5, again that's not a square. So if you take 4 pieces, yeah, that's possible. 1, 2, 4, 5. 4 pieces together, yes. How many such squares we have? 1, 2, 4, 5, 2, 3, 5, 6. Then 4, 5, 7, 8, that's a square. Then we have 5, 6, 8, 9, that's a square. So there are 4 squares. Now if you take 5 pieces together, any 5 pieces, 1, 2, 3, 4, 5, that's not a square. 6 pieces, 1, 2, 3, 4, 5, 6. If you take those 6 pieces, that's a rectangle, it's not a square. 7 pieces together, 8 pieces together, we don't get a square. Now next possibility is 9 pieces together. Yes, 9. How much you get? 1. And look at this question here. This question, if you take 1 piece at a time, 1 piece at a time, we have 16 smaller pieces here. So S1, we get 16. And 2 pieces at a time, it's not a square. 3 pieces, it's not a square. 4 pieces, it's a possibility, yes. 1, 2, 3, 4. 4 pieces at a time, we have a square. And these 4 pieces together, it's a square. So ultimately, 4 pieces together, it's a square. The next 4 pieces together, it's a square. And next 4 pieces together, it's a square. So how many? 3 squares are there. I'll mark it with different colors. So this is first one, we go with the green. See that? 4 pieces together. Next one, we go with blue. Second one. And the third one, we go with pink. See that? So 3 such squares. So that means 4 pieces at a time. We are looking at 4 pieces at a time. S4. So we have 3 so far. Then still, that is not the end. Then we have another 4 pieces together here. Another 4 pieces together here. Another 4 pieces together here. So we got another 3. So 3 plus 3, 6. Then we have another 4 pieces here. Another 4 pieces here. Another 4 pieces here. So 3, 3, and 3. So we have 9 of them. Now we have, well, 4 pieces we have taken. 5 pieces, it's not a square. 6 pieces, it's not a square. 7 pieces, it's not a square. 8 pieces, it's not a square. But next possibility is 9 pieces together. 9 pieces together. So if you take these 9 pieces together, let me mark it. Those 9 pieces together. We'll go with, let's say, yellow color. See this. This 9 pieces together, that's a square. And we have another one. Second one here. And we have a third one here. And we have a fourth one here. So 4 of them. If you take 9 pieces together, we have 4 of them. The next possibility, we have to take all the 16 pieces together, we'll get 1 square. So ultimately, how much you get? How many you have? 16 plus 9, 25. 25 plus 4 plus 1 is 5, 30. And in this case, what we have is 14. You know what? Well, counting is possible, however, counting may not be practical. For example, if you get a question like this, counting is not really practical at all. You look at the answer choices here, 110, 130, 126, 140, etc. So counting doesn't work in this case. Rather than that, we have to have some kind of a shortcut method for this. So look at this. What I see here, this is S1. S1 is what? This is a 3 by 3 square. And S1 is 9. 9 is what? 3 square. S1 means 1 piece at a time. Then we have S4. S4, we have 4. That means it's 2 square. And we have S9. S9 is what? 1 square. So it's pretty much, if it's 3 by 3 grid or 3 by 3 square, it's 3 square, 2 square, 1 square. 3 square plus 2 square plus 1 square. And look at this one, 16, 9, 4, and 1. So 16 is what? 4 square. If this is 4 by 4 grid, if it is 4 by 4, it's 4 square, then it's 3 square, plus it is 2 square, plus it is 1 square. So if it is 4 by 4, it must be 4 square plus 3 square plus 2 square plus 1 square. How about if it is like 5 by 5? Then it must be 5 square plus 4 square plus 3 square, etc. Now look at this question. If you apply the similar method here, first of all, you need to check whether the number of rows and number of columns are equal. If they are equal, then we can apply the method we have discussed earlier. So this 7 columns and 7 rows, right? So 7 rows and 7 columns, 7 by 7. If it is 7 by 7, your answer must be 7 square plus, that's 49 plus 36, 6 square plus 5 square plus 4 square plus 3 square plus 2 square plus etc. So we know that 4 square, 3 square, 2 square and 1 square, this part is what? 30 actually. We have calculated earlier. 16 plus 9 is 25, 25 plus 5 is 30. And 30, what we have here is 25. 30 plus 25, 55. And balance what we have here is 49 and 36. 49 and 36 is 50 plus 35, 85. 85 and 55, how much is that? 85, 55, 140. Right? That's the answer. Now this is a different type of question, different type of figure. How many rectangles are there in the given figure? How many rectangles are there? Rectangle. This is a rectangle. 1, second rectangle, third rectangle, fourth rectangle. So if you count it 4 rectangles and we have a large rectangle, the answer is 5. Do you agree with that? Not really. So what happens here is, if you take one rectangle at a time, R1, so 1, 2, 3, 4. If you take 2 rectangles at a time, R2, that means 1 and 2 together is a rectangle, 2 and 3 together is a rectangle, 3 and 4 together is a rectangle. So 1 and 2, 1, 2 and 3, another 1, 3 and 4, another 1. So 3 of them. Now if you take 3 rectangles at a time, 3 pieces, so that means 1, 2, 3 together, it's a rectangle, and 2, 3, 4 together, it's a rectangle. So we have 3 of them. Oh, sorry, 2 of them. Well, some of these pieces, if you take 1, 2, and 3 together, it seems like a square as well. But square is a special form of what? Rectangle. For square, it's a special condition. For a rectangle, we have length and breadth. For the square, length and breadth are equal. But still, it is a rectangle. It comes under the category rectangle. So no need to worry whether it's a square or not. Okay, fine. Now we have 4 pieces together, R4. When we take 4 pieces together, what do you get? 1, 2, 3, 4. Together we have 1 piece. So ultimately what you get is 4, 3, 2, 1. Or 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4. Is there a peculiarity for that? These are consecutive counting numbers, right? 1, 2, 3, and 4. So what is the sum of that? N into n plus 1 by 2. So here what is n? 4. So 4 pieces. So n is 4. N into, that means 4 into 4 plus 1 by 2. So what is that? 10. So we apply the formula n into n plus 1 by 2 here. So 10 is the answer. When you count it, you get the same answer, 10 as well. But without counting, if it is possible, that's great. Now, what is next here? Wow, that's interesting. So this is another rectangle in front of us. How do you deal with it? How many pieces? 1, 2, 3, 4, 5, 6, 7, 8 pieces. That means if you take 1 piece at a time, R1, it's 8. If you take R2, that means 2 pieces together. If you take 2 pieces together, 1 and 2 together, so we have a rectangle. And 2 and 3 together, we have another rectangle. And 3 and 4 together, we have another rectangle. 4 and 5, we have another rectangle. 5 and 6, we have another rectangle. So we have 5, and 6 and 7, we have 6, and 7 and 8, we have 7. So we have 7 of them. So ultimately, it goes in order 8, 7, then we go for R3, we will get 6. So 8, 7, 6, 5, 4, 3, 2, 1. Ultimately, you need to add the numbers from 1 to 8. So if it is consecutive numbers from 1 to 8, you can apply the formula. What is it? N into n plus 1 by 2. So here n is equal to 8. So n into n plus 1 by 2. What is that? 8 into 9 by 2. So we get the answer 36. Without counting, you can get the answer 36. So if you get rectangles with a single row, these are multiple columns but single row, you can apply this method. Or if you get a rectangle with multiple rows but single column, something like this. Well, multiple rows but single column, something like this. Still, you can apply this formula. So in this case, what is n? 1, 2, 3, 4, 5, 6. So 6. N is equal to 6. So what is the formula? N into n plus 1 by 2. So 6 into 7 by 2. So there's 21 rectangles are there. So we have one column, multiple rows. This case, one row, multiple columns. This one. How many triangles are there in the given figure? How many triangles? So if you mark it as like 1, 2, 3, 4, 5, 6, 7, 8. So if you take one piece at a time, so triangle, one piece at a time, we have 8 of them. Now we have any two pieces. So 1 and 2 together, if you take 1 and 2 together, that's a square. It's not a triangle. But if you take 2 and 3 together, that's a triangle. So 2 and 3 is possible. 4 and 5 is possible. 6 and 7 is possible. 8 and 1 is possible. So there are 4. So if you take 2 pieces, we have 4 possible. Then if you take any 3, for example, like 1, 2, and 3. 1, 2, and 3 together, it's not a rectangle. And it's not a triangle. What we are looking for is a triangle here. So in this case, 1, 2, and 3, it's not a triangle. Then 2, 3, and 4, it's not a triangle. And 3, 4, and 5, it's not a triangle. 3, 4, and 5, it's not a triangle. So 3 pieces, it's not possible. Now 4 pieces, yes, that's possible. 2, 3, 4, 5, that's a triangle. 2, 3, 4, 5. Then 4, 5, 6, 7, that's another triangle. So we'll make it this way. Otherwise, it may be confusing for you. So 2, 3, 4, 5, that's a rectangle. So we have one rectangle here. And we have another one, 1, 8, 7, 6. So 1, 8, 7, 6, we have another triangle here. A couple of times I said rectangle instead of triangle, but what I mean is triangle. So in this case, we have one triangle here, another triangle. So we have 4 pieces together. We have 2 triangles so far. And is there any other possibility here? Definitely we can look for that. Is there any other possibility? How about like we take, so far we have taken 2, 3, 4, 5 and 1, 8, 7, 6. How about if we take, let's say 8, 1, 2, 3. So take it this way, 8, 1, 2, 3. So that's a triangle. And 7, 6, 5, 4, that's a triangle as well. This way. So we have 2 more triangles. So we have 4 triangles. Is there any other possible triangle here? That means if you take 5 pieces together, or like 6 pieces together, or 7 pieces together, or all the 8 pieces together, if you take all the 8 pieces together, what you get a rectangle, but what we need is a triangle. So it is not possible. But here what we get is 8 plus 4 is 12, 12 plus 4 is 16, so 16. However, do we have any other method without counting these triangles? That's what we are looking for. I'll show you something here. Let's get rid of all this kind of lines. Let's go back to the original picture, what we have here. So this is how this picture looks like when you get it for the exam. So how many pieces you have here? 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces. And this is a rectangular shape. So if you need to count the number of triangles in a rectangular shape or in a square shape, it's pretty straightforward. How many pieces here? 8 pieces. And 8 pieces. 8 pieces. And how many diagonals you have? Since it's a rectangle or a square, it'll have 2 diagonals, right? So in this case, we have 2 diagonals. So 8 into 2. So 8 pieces into 2 diagonals. So what you get is 16. So that's the same answer. We got it here as well. So without counting it, you may get that answer. Number 60. How many triangles are in the given figure? How many triangles are there? So, well, we have 1 triangle, 2, then this is not a triangle, but that's a piece of this shape, then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Total 16 pieces are there. And how many triangles? We have 1 and 2, then 4 and 5, so 2, 4, 4 plus 4 is 8, 9, 10, 11, 12. So 1 piece at a time, we have 12. T1 is 12. T1 means if you take 1 piece at a time. Now, any 2 pieces together. Any 2 pieces together, do we have a triangle? 1 and 2 together, it's not a triangle. 2 and 3 together, it's not a triangle. But if you take 7 and 8 together, that's a triangle. 8 and 9 is a triangle. 9 and 10 is a triangle. 7 and 10 is a triangle. So take 7 and 8, 9 and 10. 2 triangles. Then take 8 and 9, 7 and 10. 2 more triangles. So we have 4. So if you take 2 pieces, we have 4 of them. Then we take what? Different possibilities. If you take like 2, 3, 4, and 8, that's a triangle. Then 5, 9, 11, and 16, that's a triangle. So if you keep on counting it, the number keeps on adding, right? So it's time consuming, really. It's time consuming. What's a method? We have taken a method in this previous question. If you have a rectangle or a square shape, if you want to count the number of triangles inside, what do you do? Count the number of pieces inside, multiply that with the number of diagonals. So we'll try this. How many pieces are here? We are not really picking not only the triangular pieces. We pick all the pieces or we count all the pieces. Doesn't matter whatever the shape. So this case 1, 2. We count this as well. 3, 4, 5. So altogether we have how many pieces? 16 pieces. 16 pieces and how many diagonals? 2 diagonals. So 16 pieces and 2 diagonals. That will give you the answer 32. 16 into 2, 32. And if you want to verify, what I suggest is count it. Count the number of triangles when you get a chance. And don't miss any of these triangles we have here in this picture. It's a bit complicated because you know what? The normal triangles, you don't miss it. But some of the triangles you may miss in this counting, maybe a triangle like this. This is one of the examples. And you may have it from this side as well. See that? And of course, you may have it in the other way as well. Something like this. See this? And you may have it here as well. So, when you count the number of triangles, include all these complicated triangles as well, then you get the answer 32. Exam point of view, counting is not required. It is just for a practice. Exam point of view, the answer is what? How many pieces here altogether? 16 pieces. How many diagonals? 2 diagonals. The answer must be 32. Now, odd one out type of questions. Odd one, pick the one which is different from the group. So here, lynx, wolf, puma, and jaguar. So lynx, wolf, puma, jaguar. At a glance, this question is relatively straightforward. At a glance, well, puma and jaguar are big cats. And what is lynx? If you know what is lynx, it's pretty easy. Lynx is an animal which is from the cat family, it is slightly bigger than the normal cat. So these three are from the cat family and wolf is different. So the answer is wolf. And by the way, all these animals are carnivores. If one of the animals is Herbie, then you can classify in that way as well, that Herbie is the old one. But in this case, all the four are carnivores. So the one which is different from the group is wolf. Based on the categorization, all the three are cat family, are from the cat family. Number 18. So here we have, this is the question number. 18 is the question number. And this is 31, 61, 71, and 51. So which one is different? So if it is, let's say, three of them are odd numbers and one is an even number, then definitely that is the answer. But in this case, all the four numbers are odd numbers. And 3 plus 1 is 4. If you take digital sum, 3 plus 1 is 4. 6 plus 1 is 7. 7 plus 1 is 8. 5 plus 1 is 6. So that case, 3 plus 1 is 4. So that's an even number. 6 plus 1 is 7. That's an odd number. 7 plus 1 is 8. That's an odd number. Even number. 5 plus 1 is 6. That's an even number as well. So there is 3 even numbers and 1 odd number. So that case 61 can be the answer. Right? At the same time, if you take a closer look at this question, you can see that 31, 61, 71, these are prime numbers. 51 is a composite number. That's correct. So 31, 61, 71, 51 is a composite number because 51 is a multiple of 3. 17 into 3 is 51. So 51 can be the answer. So 61 is a possibility, 51 is a possibility. So this question is logically wrong. No need to worry about it. So this is usually happen in the exam. So you need to be aware of this kind of possibilities. So if you get a question like this for the exam, don't spend a lot of time on this kind of questions. Mark your answer. Either it's 61 or 51. Whichever you think which is the best answer, mark that answer and run away from that question. Otherwise, you spend a lot of time on the question and finally at the end of the day, that means after the publishing results, what happened? If they see that there is a logical error in the question, definitely they'll cancel that question. So don't waste your time on these type of questions if you think there is a logical error. But you know what? Don't think all the questions have a logical error if you are not sure about the answer. Some of the questions may have logical error. Some of the questions, they are perfectly all right. 1 or 2 questions may have the logical error. That's a maximum. Okay, let's go for the next one. Odd one. Choose the words which is least like the words in the group. So, actually these are not words. These are like the letters. So no need to worry about it. Choose, we'll just rephrase it. Choose which is least like the other ones in the group. You don't need to use the word. Okay, so DG. DG is the position value of D is 4, G is 7, L is what? L is 12, this is 14, and T is what? 20, and W is 23, and P is 16, S is 19. And at the same time, you may look for vowels and consonant as well. So this case, all the letters are consonants. We don't see any vowel here, so no need to worry about the vowels. So here the pattern 4 and 7, so 3 is the difference. Here it's 2 is the difference. Here 3 is the difference. Here 3 is the difference. That means, in 3 pairs, 3 is the difference. In 1 pair, 2 is the difference. 12 and 14, the difference is 2. This case, 4 and 7, 3 is the difference. 20 and 23, 3 is the difference. 16 and 19, 3 is the difference. Okay, so this case, choose the words or choose the item which is different from the group. Laos, Malaysia, Japan, Vietnam. So what we know here, Malaysia, Japan, and Vietnam, these are countries. And how about Laos? Is it a country? Well, if it is a country, Laos, Malaysia, Japan, Vietnam, all the four are countries, then we need to find a way to differentiate one from this group. However, if Laos is not a country, if let's say if it is a town or if it's a continent, something like that, then definitely these three are countries, then Laos is different. So what is Laos? Is it a country? Well, Laos is a country. If Laos is a country, then we have four countries. If we have four countries, one country must be different from others. So let's say three countries are from Asia and one country is not from Asia, definitely that could be the answer. So is there such a possibility? How about Malaysia? That's from Asia. Japan is from Asia. Japan is in East Asia. And Vietnam, that's in Southeast Asia. Malaysia is Southeast Asia. Laos, is it in Asia? Well, Laos is in Asia. So that's Asian countries. So four countries are Asian countries. Now, next possibility, what we have, if one country is an island, if all the three are not islands, probably we can think about that. So this case, Japan is an island. How about Laos, Vietnam, and Malaysia? Well, Malaysia and Singapore together, it's an island, right? That's what we can see in the map. So Malaysia itself alone, if it's an island, what's the definition of an island? All the four sides must be surrounded by the water. So Malaysia, one side of the Malaysia is Singapore. So it doesn't comes under the category of that island definition. So it's not perfectly an island. So that case, Japan is an island. So Japan is the possible answer. There is one more way of looking at it. Laos, Malaysia, and Vietnam, these are Southeast Asian countries. And Japan is a country in East Asia, country from East Asia. So it is not in Southeast Asia. So Laos, Malaysia, and Vietnam are in Southeast Asia, and Japan is not in Southeast Asia. So either way, if you look at like both parameters, or you look at that both classifications, still what is the answer? Japan. Then analogies. So analogies, we have taken a look at these questions earlier, I believe. So 30 and 42. 30 and 42. So there is some kind of connection between 30 and 42. 30 plus 12 is 42. Same way, 72 plus 12 is 84. We don't have such an answer here. What is the next possibility? Any other possibility here? This one we can take it as what? There are two ways of looking at it. One way, this is 5 square plus 5. And this one is what? 6 square plus 6. Or you can take it as what? 6 square minus 6. And this is 6 square plus 6. Either way, it's okay. So take it this way. 5 square plus 5. 6 square plus 6. And what is 72? 72, it must be 8 square plus 8. And next one must be 9 square plus 9. 9 square plus 1 is what? 90. So the answer is 90. At the same time, be aware of it. 30 plus 12 is 42. Same way, 72 plus 12 is 84. So 84, if an answer choice 84 is given among the answer choices, that's the correct answer as well. Now 11 and 24. So what is this 11 and 24? 11 plus 13 is 24. Same way, 14 and what? 11 plus 13 is 24. 14 plus 13 must be 27. We don't have such an answer here. We have 28, but no use. We need 27. Anything else you see here? So here it's 1, here it's 2. Here it's 1, here it's 4. Or this is 1 plus 1 is 2. 2 into 2 is 4. So that case it is 1 plus 4 is 5. So we write 5 here. Here it's 1 plus 1, 2. 2 into 2, 4. Or this case, it's 1 plus 4 is 5. Then 5 into 2, 10. 510. But we don't have such an answer. Or this way, 1 plus 1 is 2. 2 and 2 square. That's 4. Same way, 1 plus 4 is 5. 5 and 5 square. So that's 525. Still, that doesn't give the answer. What else we have? Any other pattern? Next possibility what we hear is 11 into 2 is 22 plus 2 is 24. Same way, 14 into 2 is 28 plus 2 is 30. Okay, so we have a good answer 30, but we don't have the answer choice 30. So again, that doesn't work. Now what we are looking for is why this 2 is here? Any particular reason 2 is here? Why this 11 is multiplied by the 2? So 11 into 2. And we tried 14 into 2. We did not get the answer. So that means there is a specific reason that 11 is multiplied by 2. So 11, 1 plus 1 is 2. So 11, look at the digits of 11, 1 and 1. So 1 plus 1 is 2. So 11 is multiplied by a number which is a digital sum of 11. So same way, 14 is multiplied by a number which is the digital sum of 14. So 1 plus 4 is 5. 1 plus 4 is 5. So 14 into 5 plus 5. Let's try that. Where did 5 come from? 1 plus 4. Here, where did 2 come from? 1 plus 1. 11, 1 and 1. Here it's 1 and 4. So 14 into 5 is 70. 70 plus 5 is 75. Yes, we have the answer. Now let's try this 9 and 64. What is that 9 and 64? 9 at a glance, what I see is 3 square. 64 is 8 square. So 3 plus 5 is 8, right? Same way 625 is 25 square. So 3 plus 5 is 8. Same way 25 plus 5 must be 30. So it must be 30 square. So 30 square is what? 900. 30 square 900. But that 900 is not among the choices. That the answer choices are more than 6,400. All the answer choices are more than 6,400. So that doesn't work. And what else we have? Anything else? So another possibility what we are looking over here is 3 square. 9 is 3 square. 64 we can take it as 4 cube. So let's say 3 square 4 cube. And 625 that can be taken as 5 raised to 4, right? So it is 3 raised to 2, 4 raised to 3, and right side it is 5 raised to 4. The next one must be 6 raised to 5. 6 raised to 5. What is 6 raised to 5? 6, how many times? 5 times. If 6 is multiplied 5 times, definitely if it is 6 multiplied 5 times or 6 times, whatever it is, the last digit would be 6. So even without multiplication, you can say the answer, it is 7,776. So 6 raised to 5 is 7,776. So that is the answer. Now number 24. Well, it says radiology is to race. Radiology is to race. What is that connection? Radiology, race. So radiology is the study of race. Same way anthropology. Anthropology is about what? Anthropology is history, or is it like human, or is it like nature? Is it like pollution? Anthropology is the study of human race, right? So that's the answer is human. And many other such, the answer is human. Many other such type of studies are there. For example, petrology. What is that? Petrology. Cryptology. What is cryptology? What is deltiology? What is ornithology? What is zoology? So these are all kind of ologies, study something. What is etymology? So petrology is the study of, is it the study of petrol? Not exactly, it's the study of rocks. Cryptology. Cryptology is the study of what? Crypts. What is crypt? Crypt is codes, right? Cryptology is the study of codes. Deltiology is the study of what? Deltiology. Deltiology is the study of postcards. Postcard deltiology. And vexillology is there. Vexillology. Vexillology is the study of flags. Now 25. Ships is to fleet. Okay, so what is that? Ships and fleet. What is the connection? So ships, group of ships is fleet. So it's a collective noun. Same way keys. Group of keys is what? Door, long, bunch, Godrej. What is it? Bunch of keys. Bunch of keys. And there are many other things which comes under the category bunch. Bunch of bananas, right? And this is pretty much, well, objects and their collective noun. What is used for their collective noun? And sometimes it is animal. Animal, what's a collective noun for animals? For example, giraffe. What's a group of giraffes? Collective noun. That's tower. What is a group of elephants? Group of elephants. Any idea? What is a group of lions? I'm pretty sure at least many of you know that. What is a group of lions? A group of lions is what? Pride, right? Pride. And group of elephants? That's parade. Group of elephants is parade. And group of monkeys? Monkey. Group of monkeys, well, it is troop. And group of owls, that's the most interesting one. Group of owls is known as parliament. Parliament. And group of crows, it's known as murder. Murder. And group of eagles. This is something interesting for you as well. So I want you to take a look at, find it out, what exactly it is. Group of eagles. And I'm pretty sure you use this one, a group of eagles, in many areas that is related to your education or at different stages of your education. Once you graduate or once you pass out from one particular course, one particular level, before you get into that, so that graduation ceremony, there's a specific name for it. So that's related with the eagles as well. So this is what exactly we have for the day. And it's a pleasure working with you. Thanks for watching. See you next time.